Okay, here are the answers to your study guide for your semester 2 final exam. I'm going to work these out for you so you can pause as you're going through. Hopefully everything will be crystal clear. And then of course if you have any questions after going over this, then I'm happy to answer them. Okay, I just want to avoid distractions while I'm trying to go over this with you, so that's why you're watching this by yourself right now. All right, so Pythagorean theorem, we love it, right? So we have a squared plus b squared equals c squared. We know that the legs are a and b, and the hypotenuse is c, right? So for this one, I have a, I don't have A, I have B, and I have C. So slightly different ways to solve both of these. For the first one, a squared plus b squared equals c squared. 11 squared plus 14 squared equals c squared. 121 plus 196 equals c squared. 317 equals c squared. Square root of 317 equals square root of c squared. So your answer is about 17.08. And then my perimeter, remember, is the distance around. So when I add this plus the two sides I know, I get about 42.8 for my perimeter. Question number 2, a squared plus b squared equals c squared. Remember, we always find a squared because b kind of looks like a 6, right? And we don't want to confuse ourselves. So a squared plus 18 squared equals 30 squared. A squared plus 324 equals 900. This is where I have that extra step. I have to subtract the 324 from both sides. A squared equals 576. So A is actually equal to 24 exactly, so that's nice. And then 24 plus 30 plus the 18 for my perimeter is 72. Questions 3 and 4 are very similar. We're finding the distance between these points, so I'm going to plot them. And then over 7 and up 8. So what I do here is I connect these 2 points, and then I draw the rest of a right triangle to use the Pythagorean theorem. So this is worth 3 spaces, and then from here to here is worth 13. So then I do my a squared plus b squared equals c squared. 3 squared plus 13 squared equals c squared. 9 plus 169 equals c squared. 178 equals c squared. Square root of 178 equals square root of c squared. So your answer should be C is about 13.3. Remember, we have to use the about sign because 178 is not a perfect square. So now I'll do the same thing here. -9, +3, -1, -6. I connect these two because I'm trying to find that diagonal distance. I use Pythagorean theorem to create a right triangle. I'm going to end up with 8 for this distance and 9 for this distance. A squared plus b squared equals c squared. 8 squared plus 9 squared equals c squared. 64 plus 81 equals c squared. 125 equals c squared. Take the square root of both sides, and I end up with 11.1. C is about 11.1. Let me make sure that's right. Let me put 125 square root. Oh, that should be 11.2. I should round up to 11.2. There we go. About 11.2. Okay, next page. Scatter plots. Everybody loves a good scatter plot. I'm going to get out my ruler for this one. Hold on a second. All right. Question 5. Well, first of all, let's look at the scatter plot. We have the number of hours worked, and we have, hold on a second. Sorry for the slight confusion there. Number of hours worked and the recreational activity hours. So you can see there's a relationship between working and relaxing. The more you work, the less time you have to relax, and that's just life, people. I don't know what to tell you. One of the things we need to pay attention to is that these increments go in numbers of 10, and these increments only go in 5s, and that's going to be important when we're finding our slope. So, first thing says, describe any overall association of the data in regards to the direction and form. Okay, well, it's negative, right? Because it's going in a down from left to right form or direction. And then our form is linear because it does go in a linear pattern. It's not a straight line, but we can see how we would be able to create a trend line. Number 6 says identify any ordered pair that's an outlier. Okay, this is clearly an outlier, right? So our ordered pair is 70. We'll say about 38 because we go over 70 up to 38. Describe in context how this ordered pair does not fit the overall pattern. Well, obviously, we can see how the more people are working, the less recreation time they have. So it's kind of confusing and a little suspicious if this person's working 70 hours. How do they have all this recreation time, right? So a person working 70 hours wouldn't have 38 hours of rec time. And I'm just going to say rec as in recreation time. I don't want to write out that whole word. Okay. Then it says graph a trend line. Cool. I'm going to make a trend line here. Remember, our trend line is as close to as many points as possible. Doesn't have to touch any. It might touch some. Okay, so there's my trend line. Not bad. Write an equation of your trend line in slope-intercept form. All right, remember, slope-intercept form is y equals mx plus b. M is my slope. B is my y-intercept. So I need to find my slope, and I need to find my y-intercept in order to create that. So my slope, remember, is rise or fall over run. So if I look up here at my graph, I'm going to find 2 perfect intersection points. They just happen to be on my trend line. That doesn't always happen, but it does this time. So my slope is negative 10 because I fell 10, and then over 20 because this is worth 10/20, this is worth 5/10, which can simplify to negative 1/2. So there's my slope. My y-intercept is where the line crosses the y-axis. So my y-intercept is 0, 40. Cool. Now I'm going to take my slope and my y-intercept and put it into the equation. Negative 1/2 x plus 40. There's my equation of my trend line. Now let's interpret these. Well, what does the slope mean? So my slope is negative 1/2, and the top means negative 1. This is my rise value. So 1 less hour of rec activities. Per, and then the bottom is 2 hours, right? Hours of work. Per an extra 2 hours of work. So every extra 2 hours I work, I can prepare to lose 2 hours of recreational time, right? The y-intercept, which is 0, 40, represents recreational time, activities, if you work 0 hours. Now the catch is you'd have a lot of time to do recreational activities, you'd have no money to do it. So that's not a good strategy, not a good life plan there. but that's what it represents. Okay, number 10 says use your equation from item 8 to predict the number of recreational hours a person will have if they work 35 hours. So remember, my equation is y equals negative 1/2 x plus 40. So I'm going to put the 35 where the x is. So y equals negative 1/2 times 35 plus 40. So in my calculator, if I took negative 0.5 times 35, I'm going to get negative 17.5. Add the 40. So then y will equal 22.5 hours of rec time. Right? If you really want to get rid of rec time, children will do it for you. Just kidding. I like my kids. Okay, number 11. Use your equation from number 8 again to predict the number of recreational hours a person will have if they work 120 hours a week. Wowza. So here we go. Y equals negative 1/2 x plus 40. Y equals negative 1/2 times 120, because that's how many hours they're going to work, plus 40. Y equals negative 60 plus 40. Wait a minute. Y equals negative 20. Well, you can't have negative 20 hours of recreational time. So the way you interpret that is 0 rec time. If you're going to work 120 hours a week, you're not going to have time left for much else. So even though our answer is negative 20, we interpret that back to the scenario saying you have time for nothing else. You're lucky if you're eating at this point. Maybe a little sleep in between. Okay. Probably have a lot of money, but you don't have time to use it. See, it's like you got to find that balance. Either you have all the time in the world and no money, or all the money in the world and no time to do anything. So that's why people become teachers, because then we have the summer where we can kind of do stuff with some money that we might have from our job. Again, I joke. Okay, here we go. Transformations. You guys love transformations, right? So we have this trapezoid here. We have the ordered pairs of the trapezoid. We're going to do the transformations. Whew, they want us to rotate 270 degrees clockwise about the origin. So I gave you the algebraic representation. So we're going to take the opposite of y and put it here, and then leave x the way it is. So for A, I'm going to get negative 5, negative 3. For B, I'm going to get negative 5, negative 5. For C, I'm going to get negative 2, negative 6. And for D, I'm going to get negative 2, negative 2. I took all of these and I put the opposite of the y and left x there. So now I'm going to plot this. Okay, so negative 5, negative 3, negative 5, negative 5. So there's my A prime, B prime, negative 2, negative 6. That's my C prime. Negative 2, negative 2 is my D prime. So there's my rotation of 270 degrees clockwise. And now they want us to reflect it over the y-axis. So that is opposite x, y. So I'm going to take these ordered pairs, and I'm going to do the opposite of x, leave y the same. Opposite of x, leave y the same. And now I'm going to plot these. So I go over 5, negative 3. And I have A prime prime. Over 5, this should be a negative 5. Negative 5, B prime prime. Over 2, negative 6, C prime prime. Over 2, negative 2, D prime prime. So there is my compound transformation. I did clockwise and then I reflected. 14 and 15 are similar. This time we just have a cute little triangle here. So here are my ordered pairs, J, K, and L. The first one is to dilate at 1/2. So I'm going to take half of each of these values. So I'm going to get 1, negative 1, 5, 3, and 4, negative 3. So let me plot those. 1, negative 1, J prime, 5, 3, K prime, and 4, negative 3, L prime. So I've got kind of this tiny little triangle overlapping there. Now I'm going to transform it, and I'm going to do a translation where I'm going to subtract 4. We'll move to the left and up. So I'm going to subtract 4 from each x value. So I'm going to get -3, 1, and 0. And then I'm going to add 3 to each y value. So I'm going to get 2, 5, and yeah, this is going to be 0, 0. So -3 up 2 is going to give me j prime prime. 1 up 5, k prime prime, and 0, 0 give me l prime prime. All right, so there you have it. I shrunk it down and then I shifted it left and up. All right, last page. Oh, not the last page. Oh, I wish it was the last page. Okay, determine the slope of the graphed line. So my slope, I'm going to find 2 perfect intersection points. My rise is 2. My run is 3. So slope equals 2 over 3. My y-intercept just happens to be right there. It's where the y value, the line crosses the y-axis. So my y-intercept equals 0, 1. All right, for number 18, determine the ordered pair that would be a point on the graph. So if I were to graph this line, which of these ordered pairs would fit? So the hint here says, substitute the x and y values to see which pair makes the equation work. So if I put 3 in for x and 12 in for y, so if I put 12 equals 2 times 3 plus 3, 12 equals 6 plus 3. Does 12 equal 9? Nope. So it's not A. What if I put 11 equals 2 times 4 plus 3? 11 equals 8 plus 3. Does 11 equal 11? Yay! So this is my answer. I don't even have to try these two because I already found my answer. There's only one. All right. Number 19, which is the solution to the system of equations. I gave you the hint. It's where the 2 lines intersect. So we're talking about this point right here, which happens to be -2, -1. Probability. Woo, everybody's favorite. All right, we have the name of each month on a piece of paper. Place it in a hat. Use this information to answer these 3 questions. Question 20. Suppose Jason randomly picks 2 months. What's the probability that, I don't know why his name changed to Jason and Jackson. It's the same kid. What's the probability that Jackson/Jason selects any month except December on his first pick, places it back in the hat, and then selects a month that starts with J for his second pick? So any month except December is going to be 11 out of 12 months. He puts it back in the hat, so we still have 12. And how many months start with a J? We've got January, June, and July. So I'm going to cross simplify here because 3 goes into 3 one time, 3 goes into 12 4 times. 11 times 1 is 11, 4 times 12 is 48. That's the probability that he would get that selection, 11 out of 48. Suppose Jason Jackson picks 2 months. What if he selects January on his first pick, does not replace, and then selects a month that starts with J for his second pick? All right, so January is 1 out of 12. Then we know we only have 11 left because the J was picked out, the January was taken. There are 3 months that start with a J, but the January was already taken. So we have 2 out of 11. I can do some cross simplifying here because 2 goes into 2 one time, 2 goes into 12 6. I get 1 out of 66. So it's a very small probability that that would happen. If he makes one selection, what is the probability that he selects a month that starts with A or ends with BER? So that or means we're going to add, right? So month that starts with an A, we have April, in August, so 2 out of 12, plus how many months end with BR? 1, 2, 3, 4. September, October, November, December. So when I add these, I get 6 out of 12, which can simplify to 1/2. So he has the probability of 50% of that happening. All right, now we've got some volume. I'm going to give you the formula. You're going to get all the information about the image. So we just fill in the values and we go. So volume equals 1/3 base times height. Volume equals 1/3. Our base here is a square. We know the length is 5, so since it's a square, we know that both of the length and width are 5, the height is 7. So volume equals 1/3 of 25 times 7. Volume equals 1/3 of 175. Remember, to take a third of something, we divide it by 3. So if I do 175 divided by 3, volume is about 58.3 repeating feet. Actually, we could use an equal sign there because we did the repeating. So we know that that's the exact value. All right, so there's our pyramid with a square base. How about a cone? Here's our formula. We need to know the radius. It tells us the diameter is 12. So my radius equals 6, and I know the height is 11. So volume equals 1/3 of pi times 6 squared times 11. Volume equals 1/3 of pi times 36 times 11. Volume equals 1/3 of 1,243.44. I take that and divide it by 3. Volume is about 414.48 inches cubed. Oops, I forgot to put cubed up here for my pyramid. Inches cubed, feet cubed. All right. Number 25, find the volume of a sphere that has a radius of 8 meters. Perfect. All I need is the radius. So volume equals 4/3 of pi times 8 cubed. Volume equals 4/3 of 3.14 times, what is 8 cubed? 512. Volume equals 4/3 of 1,607.68. Remember, to find 4/3 of something, I multiply times 4. 4 times 1,607.68 equals 6,430.72. And then I divide that by 3. So I multiply by 4, divide by 3. That's how you find 4/3 of something. So my volume is going to be about 2,143.57 meters cubed. All right, last one. Now we're finding the last one. This one's a little confusing because it says surface area. It gives you the surface area formula, but this says volume. And this says volume. So this should say surface area, surface area. Okay, so we have a diameter of 20. We need the radius. So I know my radius equals 10 centimeters. So surface area equals 4 times 3.14 times 10 squared. Surface area equals 4 times 3.14 times 100. Surface area will be 1,256. Will be about, because we used 3.14, 1,256 centimeters squared. Because remember, area is squared. Okay, that's it. You did it. You made it. Let me know if you have any questions.